Alright, let's talk about something that's probably lurking behind your desk right now. A tangled mess of digital spaghetti that makes everything work: network cables. I know, Wi-Fi is king, right? We all love the freedom of browsing from the couch, or, let's be honest, from the bathroom. But here's the thing. The backbone of that glorious wireless freedom is almost always a physical, tangible cable. These unsung heroes are the superhighways of the internet, carrying data from your router to your gaming PC, from a server farm to your favorite streaming service. They are the fundamental building blocks of any reliable network, ensuring that your connection is fast, stable, and secure when it absolutely matters most. Think of it this way. Wi-Fi is like sending a message with a paper airplane. It's convenient and works great over short distances with a clear path, but a gust of wind or your neighbour's microwave can send it off course. A network cable, on the other hand, is like a pneumatic tube system, a direct, protected pipeline for your data. It's a dedicated physical link between 2 points, which means less interference, lower latency, and often much faster speeds. For anything that needs a rock-solid connection, like competitive online gaming, streaming 8K video, or transferring massive files for a video project, you simply can't beat the reliability of a good old-fashioned wire. So, what exactly are these things? At their core, network cables are just insulated wires designed to transmit electronic signals, your data, from one device to another. These devices could be your computer, a router, a network switch, a printer, or even a smart TV. The connectors at the end of these cables are the universal translators, the standardized plugs that allow different pieces of hardware from different manufacturers to speak the same language. Without these standardized cables and connectors, connecting to the internet or even just printing a document over your home network would be a chaotic nightmare of proprietary plugs and incompatible systems. They are the silent, essential infrastructure of our digital lives. The importance of understanding these components can't be overstated, even for a casual user. Knowing the difference between a Cat5e and a Cat6 cable might sound like nerdy jargon, but it can be the difference between a smooth, buffer-free movie night and a frustrating, pixelated mess. It can mean the difference between winning and losing in an online match because your connection was just a few milliseconds faster than your opponent's. In the world of tech, especially when it comes to performance, the physical layer, the cables and connectors, is the foundation upon which everything else is built. A weak foundation means the whole structure is compromised, no matter how fancy the hardware on top is. When you think of a network cable, you're probably picturing what we call a twisted pair cable, most commonly an Ethernet cable. If you look inside one of these, you'll find 8 copper wires, twisted into 4 pairs. Why the twist? It's a clever bit of engineering, actually. Twisting the wires together helps cancel out electronic noise or interference from other wires and nearby electronic devices, like power cords or fluorescent lights. This keeps the signal clean and your data intact. The most common types you'll see are category cables like Cat5e, Cat6, and Cat6a. The higher the number, the better it is at handling higher speeds and frequencies, which translates to a faster, more reliable connection for your devices. Now, for the really high-speed stuff, we have to talk about fiber optic cables. These things are on a whole other level. Instead of sending electrical signals through copper wires, fiber optic cables transmit data using pulses of light through incredibly thin strands of glass or plastic. Think of it as data traveling at the speed of light, literally. Because they use light, they are completely immune to electromagnetic interference, which is a huge advantage. They can also carry mind-boggling amounts of data over extremely long distances with very little signal loss. This is the technology that powers the internet backbone, connecting continents and cities across the globe. So what's the practical difference for you at home or in the office? Ethernet cables are the workhorses for most local networks. They are affordable, durable, and more than capable of handling the gigabit internet speeds common in many homes today. They're perfect for connecting your PC to your router, your game console to the wall jack, or setting up a small office network. They're easy to terminate and install, making them the go-to choice for everyday networking needs. You get fantastic performance without breaking the bank, And for most applications, it's all the speed you'll ever need for a reliable and snappy experience. Fiber optic, on the other hand, is the premium high-performance option. You might see it used for the main internet line coming into your house, what's known as fiber to the home or FTTH. It's also the standard in data centers and for connecting network switches between different floors in a large office building. While it offers unparalleled speed and future-proofing, the cables and equipment are more fragile and expensive than their copper counterparts. For most home users, the run from the wall to your computer will still be Ethernet, but the incredible speed you're getting is often thanks to a fiber optic line running down your street. A cable is useless without a way to plug it in, and that's where connectors come in. These are the plastic or metal plugs at the end of the cable that physically link it to a port on a device. The most famous and instantly recognizable network connector is the RJ45. This is that slightly chunky, clear plastic plug you find on the end of virtually every Ethernet cable. It has a little springy tab that makes a satisfying click when you plug it in, letting you know it's securely seated. This design ensures a solid physical and electrical connection, preventing the cable from accidentally falling out and interrupting your data flow. The RJ45 connector is designed to work with the 8 wires inside an Ethernet cable, with each wire having its own specific pin position inside the connector. This precise arrangement, known as a pinout, is critical for the cable to function correctly. While you probably won't ever need to worry about the pinout unless you're making your own custom-length cables, it's a great example of the standardization that makes networking possible. It means you can buy an Ethernet cable from any brand and plug it into any device with an Ethernet port, from a laptop to a network-attached storage device, and it will just work. It's a true plug-and-play hero. Of course, RJ45 isn't the only player in the game, especially when we venture into the world of fiber optics. Fiber cables use different connectors because they need to align the tiny glass fibers with microscopic precision to ensure the light signal passes through with minimal loss. Common types you might encounter include LC and SC connectors. They often have a square or rectangular shape and use a push-pull or latching mechanism. You'll typically see these on the equipment from your internet service provider or on high-end networking gear in a business environment. They serve the same purpose as an RJ45, but are engineered for the unique demands of light transmission. Ultimately, the connector's job is simple but crucial. Create a reliable temporary bridge between the cable and the device. It needs to be durable enough to be plugged and unplugged many times without wearing out, and it needs to protect the delicate wires or fibers inside. Whether it's the familiar click of an RJ45 or the precise alignment of an LC fiber connector, these small components are the critical handshake points in your network. They are the gatekeepers that allow data to flow freely and reliably from one point to another, ensuring your digital world stays connected and runs smoothly. So how do you apply all this knowledge in the real world? Let's start at home. For connecting your main computer or game console directly to your router, an Ethernet cable is your best friend. Look for a cable labeled Cat6 or Cat6A. These provide excellent performance for gigabit internet and beyond, ensuring you get the lowest latency for gaming and the fastest speeds for downloads. If you're just connecting a smart TV for streaming or a printer, a Cat5e cable is perfectly fine and a bit cheaper. The key is to use a wired connection for stationary devices that demand speed and stability, leaving the Wi-Fi bandwidth free for your phone and laptop. In a typical office environment, the principles are the same but scaled up. Workstations are almost always connected via Ethernet cables to wall plates, which then run to a central patch panel and network switch in a communications closet. This structured cabling approach provides a reliable, manageable, and secure network for the entire business. Here, Cat6a is often the standard to support high-speed data transfer between computers and servers, and to future-proof the network for the next decade of technological advancements. Fiber optic cables are then used as the backbone, connecting switches between floors or linking separate buildings on a campus to handle the massive aggregate traffic. When it's time to buy a cable, don't just grab the cheapest one you can find. First, check the category rating. As we discussed, Cat6 is a great all-around choice for modern home networks. Second, consider the length. Get a cable that's long enough to reach without being stretched, but avoid having a massive coil of excess cable, as it can be messy and, in some rare cases, cause signal issues. Also, look for cables with snagless boots on the RJ45 connectors, that little piece of plastic that protects the locking tab from breaking off when you're pulling it through a tangle of other wires. It's a small feature that can save you a lot of frustration. In the end, while we often focus on the power of our processors or the speed of our internet plan, the humble cables and connectors that tie everything together are just as important. Choosing the right cable is a simple step that has a massive impact on the quality and reliability of your connection. A good cable is a long-term investment in a stable, fast, and frustration-free digital experience. So next time you're troubleshooting a slow connection, don't forget to check your physical connections. Sometimes the most powerful upgrade you can make is simply swapping out an old, low-quality cable for a new one.